answers from that film. From the film.
Oh. Yeah.
What you read about catfish, you say like there's no answers.
They are quote unquote detritivores, they eat waste. How many of you on Tuesday when you did that web search about shocking food system facts, how many of you saw that statistic about food waste? How much of our global food supply is wasted? 1/3 to 1/4? Imagine how slick it would be if we could turn waste food into high quality feed. That's why catfish. They eat farm waste, they eat spoiled food, they eat like leftovers from like a butcher, like they eat pretty random food scraps that aren't likely to be useful. They turn them into catfish, which is edible and kind of tasty. By the way, I don't know if you all saw my Facebook post last night, but so did my chickens. If you ever have like stale chips, moldy bread, miscellaneous like meat trimmings, they love to eat chicken. If you have any, yeah, humans are the only predators that have a taboo on cannibalism. But they'll eat pretty much any leftover food. They don't really get a lot of leafy greens. It's mostly just water and roughage for them. But if you're gonna have like cereal or grains or bread or chips or any of that, they would love you for it. Anybody else questions about the movie? I'd like you to change something. For number 37, a lot of you wrote a quarter, because that's what the film said. Today that number is actually almost exactly 1/2. Like a few years ago, 7 or 8 years ago.
And now it's half.
Oh yeah, this was like easily one of the biggest growth opportunities in food production in the last century. A few companies really cornered that market, got really stoked. So the amount of aquaculture has really grown. We're up to about half of the world's seafood, mostly in Asia, mostly invertebrates, shellfish, shrimp, oysters. Any other questions from the movie? Yeah, Kyle, checking my math? Yeah, it is. Okay, now. You all had the soil salinization lab on Friday. I want to be totally, absolutely clear on how to get set up for that. Because in previous years, this was a place where a lot of my classes lost points, and this year I want to like totally set you up straight. Please take out your soil salinization lab handout and a blank sheet of paper. Yeah. That's nice, sir. Are you doing the impression that I deliver papers? Oh yeah, welcome to APES. Yeah, my name's Jose. The plan will be in the papers. Yeah, okay. Nice.
You don't want to Theo today.
I'm just not a nice person, I think, probably.
It's okay.
I love Theo.
It's okay.
Yeah, I know he can, yeah.
I'll just cry later.
Check it out. Why are we doing this lab? And information to consider while designing this experiment. Then put it on your head to show me you read. Why are we doing this lab? And the second, information to consider. Please do this now. Christine knows me.
Kidding.
Is it hidden?
I hope so.
For those of you who are wondering, I do this thing with the papers on the head so that students who are still reading can kind of keep focusing without feeling pressured. But thank you for doing it. I know it's kind of weird, but it is sort of intentional for me. As you've seen, saltwater accumulation on farms is a leading problem for soil management. It's also one of those simple physical processes that the College Board loves to ask you about.
The 3 stars.
Yeah, it's definitely 3-star stuff. The problem is that when salt water evaporates, the salt is left behind. And all water has a little salt. If you farm along a river, it doesn't matter because that water gets flushed out by occasional flooding. But if you farm inside of a valley, especially a very arid environment with a lot of evaporation, that can be really bad. Today, Israel has lost about 20% of their food production capacity to soil that's become too salty to grow food on. I don't know if you realize that there's a certain level where salt water won't sprout seeds anymore, so you just can't grow food in salty dirt. Water evaporates, salt's left behind.
How do you get rid of the salt?
Well, the only way to get rid of it is to flush it. So that's how to solve the problem. But your experiment Friday will be to determine how much salt it takes to ruin soil.
For a specific seed or?
We will use one type of seed, but FYI, it's a fairly safe average on seed hardiness, so it's the number we get is pretty close to the science number if everybody does the work right.
Is this the one where we bring in the tooth into soil?
No, it's not. Thanks for asking. That one's later. There's 2 labs, salinization and soil lab. Soil is due the day that it says it's due on the whiteboard.
Yeah.
But I'm now talking about this Friday's lab. So check it out. I have explanations for you so everybody understands. Because you all realize that from now on, labs have 2 assignments.
Yeah.
The paper with your notes that show you're ready to go, and then the paper with your post-lab questions that show you've looked at your results. Yes? Keep in mind that each of these 2 papers will be labeled as normal. They'll both be presented for a stamp as usual, and they'll both be turned in with the exam like all the rest of the unit paper. Yeah?
Is on the board how there's an arrow, is 4.2 due on Monday or Friday?
The actual date
Okay.
is now Monday. The arrow shows you that that's a change from what I put on the board Monday. When that was
Okay,
absent, it
gotcha.
said Friday, but that was wrong.
Okay.
That's now accurate.
So do you do the labs in class or do we do them?
You'll do the labs in class. So what you have to do at home is just get ready to come in and work. That's why you can't use the handout. You got to show me like, yo, I'm ready to go. And I'm going to give you time today to get ready to go. Here it comes. You'll be working in groups of 3. Each class may have 1 odd-sized group. I'll give you your groups in a minute. Next. You'll have 6 data sets. I will give you some Petri dishes. And you'll set them up like this. Lid, paper towels, 10 seeds, paper towels, bottom, a sandwich. And into that sandwich, you'll add some salt water mix and we'll see if it sprouts. Like that. In about 2 weeks, you'll open it, it'll smell bad, and you'll be able to see if that amount of salt allowed sprouting or prevented sprouting. Okay? You'll pick the solutions, that's your experiment, please look up. You'll have 6 data points. You'll have to have a control, which is 0% salt, just fresh water, to make sure your seeds are good and everything. And then, you'll pick 5 other salt water concentrations. You'll mix them yourself. It's up to you and your group to decide, should we do a 0.5, should we do a 3? You know you don't have to go over 3.5, because salt water in the ocean is 3.6. I think you might have read that just now. Possibly you read that? So we don't have to go over 3.6. We already know that ocean water doesn't sprout seeds. It's going to be somewhere between 0 and 9. Please look up. I'll put you into your groups in a few seconds. You will choose your 5 experimental salinities. Then when you show up on Friday, I'll give you petri dishes, I'll give you paper towels. You can do like the, what's it called, paper doll thing, where you like cut out, you like fold it all up, and you cut out the shape, and you get a whole bunch of little circles. So you can make little like discs for your paper towel sandwiches. Got it? Then you'll take some fresh water, and you'll take some salt water, and you'll mix, and you'll get your blend of salts to do your different experiments. So today I want you to also come up with those recipes, and I'm going to give you 10% salt water. So look at this handy formula. If you want 2% salt water, let's say that's one of your experiments is 2, you would need, please look up, 2 milliliters of my salt water and 8 milliliters of fresh water. Because it's 10% salt water, you basically take like that amount in milliliters and you combine it with the remainder to fill up to 10 ml. And you get a little bottle that you can pour in. Questions? All I need you to do today is make your notes for your procedure, because you won't be allowed to use this on Friday. You will be allowed to use your notes. Everybody's notes must be independent. You're going to work in a group of 3, but your group members might be absent on Friday, so everybody has to have their own notes. Are there any questions?
Are you gonna make the groups?
Yes, I am, and I'm going to give you 15 minutes to work with them. Any other questions?
Yeah.
Yeah, bro.
So all we need to do for tomorrow is have a sheet with our 5 experimental salinities and our formulas. That's it.
And, you know, any notes that you'll need to how to build the thing and stuff, because I'm going to clear off the board and you'll be on your own.
Okay.
So you just got to have, like, whatever, you know. Imagine that, like, you're absent. Do these guys know how to run the lab that you had in mind? Do you all agree what your salinities was, what the mixes were, how you're going to set it up, how many sheets on the bottom, how many on the top, whatever?
Okay.
Yep.
Why can't we use the lab?
The reason that I don't like students to use the lab write-up is I like to make labs that use about 50 minutes of class time. So if somebody shows up and has to do that reading and then has to ask their partner, like, yo, what are we doing today? And then their other partner has an opinion that's maybe a little bit different, it just wastes too much time. Coincidentally, that's also how they do it at university, so it's practice for that conceptual setup.
How many layers do you need of their towel?
I go 3 and 3, but you might want to go 5 and 5.
Okay.
At some point, you get too much paper towel and it makes it too moldy. Look at me. Watch. You three plus whoever sits there. You 3 including whoever sits there. You 3. You can join their group. You're the one group of 4. You 3 including Tamur. You 3, and you 3. Everybody got it?
Wait, what's it?
Yeah, like that. Yeah, like that. Anybody else? Okay, the rest of your period is yours. Good luck working with your group. Pick your solutions, make your recipes, write your plans.